From now on, in which one of my videos, I'll be giving an important hack or tip about data science, which will make a huge difference for you guys who are watching my videos. So it can be about some tool which recently announced a new feature, or some tool which can perform operations much faster than the existing industry standard. Hello everyone, welcome to the second part of the project, Air Quality Index Prediction using LSTM neural networks. In the first part of this video, which I had uploaded recently, we discussed about importing the required libraries, reading in the dataset or the CSV file, and then understanding the statistical distribution of values in each of the columns using various statistical methods available in pandas. And we also removed all the null values, and we also divided 20% as the testing set and then 80% as the training set. I highly recommend that you watch the first part because it makes more sense and it will be easier for you guys to understand if you follow a project from the start. There might be some instances where you might get doubts when I'm doing some particular steps in this part of the project. There are high chances that those kinds of questions have already been answered in the part 1. So watch that and then come back to this if you haven't yet watched the first part. Now let's get into this part of the project. The first step we'll be performing is normalization, or scaling the values of all the columns or all features to a particular range so that our model doesn't think that higher magnitude means higher importance or lower magnitude means lower importance. So we will be normalizing only the target class or the label. In this case, our target class is PM2.5 column because first we'll be predicting the values of this pollutant. Out of all the training rows, I'm taking only the PM2.5 column and assigning it to a variable called train norm. Since the normalization works only for arrays, I'm converting this train norm into an array. By default, the data type considered in Python is a list. So train norm will be a list. So using the asArray method from NumPy module, which is NP, I'm converting train norm into an array. After converting our list into an array, the next step is reshaping. So here we have supplied the second parameter or argument as -1, 1. In the reshape method, specifying -1 means we are telling the NumPy module to detect the size based on the other parameter. So here we have given 1. So essentially we are saying that we need only one column and then you decide how many ever rows you need. After that, and then we are assigning it to the same variable train norm because we essentially want to override that data. Then now comes scaling all the values. So we can use min-max scaler from scikit-learn, and then it takes as argument feature range where it's a tuple. So here we specify the starting range as 0 and the ending range as 1. It is a very common practice and it's a standard practice to scale all the values between 0 and 1. So essentially here we are creating the min-max scalar object and we are creating the instance of an object in the scalar variable. Now that we have defined the actual object, now we have to fit this particular training data to this object. So we can use the method fit transform and then pass in the argument or parameter as what we want to normalize. So here I'm passing in train now and then you can assign it to the same variable. So here I'm printing in the first 4 values in that column to get an idea of how this normalization has taken place. PM 2.5 column originally looked like this. Apart from the value, there was also the index for that value, but for our predictions we need only the value. That was the reason here we specified 1, which means we only want one column. That means only the value should be present, and then -1 for the numpy to determine how many ever rows it wants. Even after the procedure of normalization and scaling, null values are possible. So even if the value is 0.0003, we can also consider it a null value because the tolerance is so low and it can cause some problems for the predictions of our model. So here for identifying the number of null values, I'm running a for loop until the range of the list. So here in this case, train norm is the list which we have normalized and scaled. And then we are specifying in if condition if the entry in the train norm. So train norm is the actual array and then I is the index. If that is equal to 0, increment the count variable which we initially initialize to 0, and then we can print the count value at the end of the for loop. So this will give the total number of null values in train norm. Now we have to drop all the null values. Here we can use the power and concept of Boolean masking in pandas. Train norm not equal to 0 results in a Boolean output where the values in the output are only true or false. And then when you use this as the index into train norm, you will get only the output as those rows where the result was true. So essentially we're removing all the null values. Okay guys, let me give you today's bonus hack. The first one is you have to build robust data skills, and you should also have a practical skill set. It doesn't matter what kind of data skills you have unless you're able to apply it correctly and the right metrics to the business case or the client's problem. And you need to have that kind of data skills which can perform efficiently, even saving all the computational resources, and which can run on high performance logic. The second bonus hack for this video is that you need a clear understanding of the business case. Suppose the problem requires predicting metric A and then you somehow predict metric B. That doesn't make sense, right? Because that is not what the problem requires, and that shouldn't be the solution. So you need to have a clear understanding so that you're able to define the metrics and build the model accordingly so that the solution is being answered efficiently. Now that we have completed the procedure of normalization and scaling for training data, we have to do the same for testing data so that the accuracy and the predictions we get resemble the actual performance of the model based on the training set. So here again, using X test, we index by taking only the PM 2.5 column, since we want to normalize only that, and then we convert it into an array and then reshape it by specifying the second parameter as -1, 1, where we tell that we need only one column, and then we tell numpy to determine how many ever rows it needs, and then by creating the min-max scalar object with a feature range of 0 to 1, and then we have to use the fit transform method and then use as argument the test norm data, and then by fitting it we can get the scale data. Just to know how it is scaled, I'm printing in the first 5 values here using a for loop. As usual, again in the testing set, null values are also possible. So I'm using a for loop as before, and then if condition, if the value is 0, then increment the count which was initially initialized to 0. So here there are 129 null values. Null values are there even in the testing data set after normalization. So we use the same concept with index as test norm not equal to 0. Index it into the test norm data itself and then overwrite the test norm. I'm here printing the shape of both train and test. Here there are only number of rows displayed and not the number of columns because there is only one column. So 24,569 entries in training and 6821 entries in testing. Now since this is a time data set, here we have to be taking a sequence of values for prediction rather than just a single value. If we take a sequence of values, then it will take into account the correlation between the data points, and then those neighbors should be considered to see how the value is changing over time. For this we will implement a function. The name of our function is split sequence, which will split a sequence of numbers or the dataset that we pass into. So as usual, and it's obvious that the first parameter is the input data, then the second parameter is the number of steps. So in each grouping, how many number of values should be there? First, I am initializing two empty lists, X and Y, that is for training and testing. And then I will loop until the length of the sequence using the range function. I can get the length using the len function. So running a for loop, I first determine the ending index. So suppose I'm at I, and then since we want number of steps, which is n steps, so if I add n steps to the current index, I will get the ending index. And then I'm performing a if statement where I'm checking if the ending index is actually greater than the sequence, means we're beyond the sequence. Since the indexing starts from 0, we can do len of sequence -1 to get the actual length. If so, we break. If we don't follow the condition, we come to this line. So here I'm using the current index and the ending index. I'm accordingly gathering the training data and testing data, which is nothing but sequence X and sequence Y. So sequence X will be starting from current until end, and then sequence Y will be the sequence of the ending index. So now we have, for the current iteration, we have sequence X and sequence Y. We have to add this to the empty list we had created above. So we can use the append function to add the values to those lists. And then since most of the functions and we like to work with arrays usually, so I'm using the array of operator to convert into arrays. And then I'm returning both the X and Y. Here the number of features is 1 because we'll be predicting a single value, that is only the value of the PM 2.5 pollutant. So we have to reshape all the sequences which have been split into the format number of rows, number of columns. and then the third argument will be number of features, as you can see here. And it's not very important because number of features is 1 in our case. So in the output here we can see that there are groups of 3 values, because 3 is like the best number in time series analysis to group the values for. So I'm defining n steps as 3 and then calling the split sequence function on train norm with n steps as 3, and then defining number of features as 1. I'm using the reshape function of xsplit train here, and I'm printing the first 5 entries. So here we can see that we have grouped into values of 3.